here? What we got here?
So you recording?
Yep.
Right on. Okay. So we replaced. We removed the fan and the solar wire gland. There was definitely water coming in with those. So we redid those and we applied Dicor self-leveling sealant up there, so it's bomb-proof. I got a couple photos of it. Of course, you can jump up there and look at it as well. So I ran new wires as well because I don't like having any joints in wires if I don't any joints or any seams in wires if I don't need to. So I ran all new wires from where they intersect with the solar, existing solar panels all the way down in here, back through this cabinet. You can see that those wires back in there, just strapped up. Drilled holes down here, and ran them down into here, where we have our solar system.
Ah, there it is.
Yeah, so here it is. So this is your solar charge controller. I got 40 amps out of this thing. So we'll trace this down. So this is your main solar wires coming from the roof. These are 10 gauge wires. These come in to this right here. Now all that this is actually, this is a breaker, but it's not intended to stop like if there's a surge of too much energy. The solar panels can only generate so much energy. These wires are more than capable of handling them at the voltage that they're at. So all that this is for is if there ever needs to be any service on those things up there, or you need to make sure you don't have any juice coming into anything downstream, you throw these.
Ah, so I don't have to unplug them to or cover them up before I disconnect them, you're saying?
Exactly.
I understand. Yeah, sure.
This just disconnects you like that. And these breakers are a little weird because when they're off, they're green. And when they're in the universal signal for on, which is, it's kind of like the digital, right?
Right.
1 or 0. That means on, they have these red, these red kind of panels.
Yeah, it is kind of backwards.
It's a little backwards,
yeah,
so
sure.
I don't know what the hell. It's a nice breaker. I've used them before. They're good, solid feeling things, but somebody in the design department seems like they kind of screwed the piece on that.
Sure, yeah.
Anyway, so that's all there. This comes out, goes into the PV, the photovoltaic section on this guy here, then comes out into the battery out. And what this does then is we go into another breaker right here. And so that's controlled right here. And it's the same thing. We turn it on, off right there. And then we always put a breaker on the positive line. So out of there, into there, and then this is the one that takes it down to the positive and negative bus bars.
Okay.
And you'll notice that there's a change in wire here. We go from a 10 gauge wire to a 6 gauge wire when we come in and out. Well, that's the whole thing that this does is it takes the voltage up. Your photovoltaic cells are typically 19 to 24 volts. Higher voltage, we can push more amps with a skinnier wire. But when we change it down to 12 volts, you need a thicker wire to carry that same equivalent amount of energy. It ends up being lower voltage but higher amperage. So that's why we go from 10 gauge to 6 gauge wires. This is your Bluetooth module right here. So everything that we see here, and there's a book that can tell you all about this as well, but essentially there's error codes. This has to do with these ports that we're not using currently, but you could use if you wanted to control a load, like if you wanted to charge something else or hook up something else. There are some future options down the road.
Can you hook up? I can hook up my Blue Eddy to that?
Potentially, yeah, potentially. We'd have to figure out how to interface it.
Interesting.
But it's a load port, and what this code does, there's a little bit of information. It's not terribly detailed in here, but what I gathered from it is that you can tell it to do enact a certain protocol, essentially. When we have energy coming in, and I'm not sure if it prioritizes charging the main batteries. I think based on the code, the number that you put in here, it tells it to do a different thing.
Okay.
One or other things. You have all these different options you can do. This is just, we're not using it, so it's just on manual. It's not doing anything right now. But you could say, okay, when the sun is shining, I want this to be putting energy towards essentially this, your Blue Eddy. Or you could charge it to run run your cooler or something like that. If we set it up that way. So it would take a little bit of figuring. I've not used this before with that function, but it seemed pretty straightforward. It could be a nice option.
Okay.
Essentially, if it's just for, say you already say these are full, and you got just this excess energy that's not being gathered. Well, hell, why not gather it to do something good with it?
Right.
So kind of TBD with that.
Gotcha.
Temperature. That's like amp hours. I think this is like a history. This means like battery to your load. So I'm guessing you'll see this amp hours go up as you use it. This is solar panel into the battery. So far there's no history with that. 0 amp hours from the battery to the load. That's your voltage of your battery. Voltage is actually the most direct way to measure the current state of charge of a battery. But we'll also have, if you go here, they give it in a percentage. Now it's a little tricky. Different batteries, lithium, or you have lithium, of course, but different temperatures, they have different potentials, and it's a little confusing. Don't worry too much about it. You got a huge freaking capacity. You're gonna be good. This is where most people will live, looking at the percentage of it like that.
Okay. Can I case this up for protection, or does it need to breathe similar to the stuff in the back?
It does need to breathe when you're using it. Yep. This guy needs to have 6 inches above it and 6 inches below it is what they say. But I'm thinking, and of course it sticks out a little bit, but if you were to relocate this out, you might be able to have enough room to actually hang things in front of it too. This is fine. There's nothing heat-wise about this, but you just want some energy flow through.
Okay.
So there's two things I'll move on to talking about. One is, so we have this Bluetooth module, like I mentioned to you. I think that I think you have the choice of doing either one or the other of these. I gathered that you can't do both of them.
Right.
Because we only have one port on this to plug into. So this is what I call this, the Renogy 1. You could choose to use this if you wanted to. I didn't install it. It's fairly easy to install. I could walk you through it, or you'd totally figure it out, not a problem. You essentially hook it up to the batteries back there, and you'd run it, and you could probably put it on the side up here, or maybe up in the front right there. But essentially, all that this thing does is everything that you can do with the Renogy app. So there's an app called, what the hell is it called? It's called the Renogy DC Home app. DC Home Renogy. And you just look that sucker up and download it from the App Store. And what this does is when you get on it, you're going to locate a new device. You're going to hit plus, you're going to say add devices, and it's going to search for it. Now this thing has this Bluetooth module kicking, so it's available to be found. I already found it, so maybe it's confused because
so that app's also it interfaces with the Bluetooth and the batteries themselves.
There's no Bluetooth in the batteries.
I thought I bought
in the 200 amp ones they had Bluetooth in them. These 100 amps do not.
Oh, I thought it was backwards with that.
I know, and I was a little confused. about that, but I think so. Okay, so it found it here. So it found the controller. This is your solar charge controller. I already found it, so I'm not gonna. Well, I suppose it's the same thing. We'll just hit confirm. Or not. There we go. Oh, wait, is this? Oh, is this the? Okay, wait, what? Huh? What?
There they come.
Well, there they go.
Okay,
right, good.
Because I was like, how do you know that? How am I going to monitor the battery capacity?
Yes. Well, it's interesting because this actually, via this, it seems to be tracking the battery capacity.
Oh, it does. Okay.
It seems to be.
Okay.
Yes. I'm a little. So you can Well, but this
we'll look at the controller. We'll look at the controller anyway.
We'll look at the controller. Start with the controller. So we're going to do this. We're going to confirm that. Oh, yeah, that's really cool. I'm really glad to see that. Okay.
Oh,
here
wow.
We go.
Okay.
Okay. So what it's going to... Oh, perfect. It picked everything up and it gave us all this information. Good. So you're going to be able to monitor each battery. You see how there's a little bit of imbalance in them. So, it'll just... That's okay if there's a little bit of imbalance. It's not a huge deal. When you start getting significantly imbalanced, and this is something that I'm not a pro on. I don't typically do individual batteries in this long series like this,
right.
So I'm not as experienced with what kind of differentials they may have. Typically, I charge them all up. I charge it for like 2 days to get this sucker at what appeared to be 100%, but it'll just work its way up. It'll kind of work its way up and down and kind of equalize itself out. So you can go in each individual battery if you want. You can rename it. You can give it a number in the line or whatever. But you go in there, and it's basically just telling you, okay, beautiful. We got 98.8% of 100 amp capacity. This is our present voltage. You can just get these various pieces of information on there. The main thing that's important to have this for is if you do ever have any problems, you can get in, you can see if there's any imbalances in the cells. And that's really what's more important. You know, it's typical to have a little bit of a voltage difference between them, just because as they discharge, as they come down, sometimes there's a little bit of a difference between them. But as they evenly go down, they'll generally all be evened out. You know?
Okay.
If you ever have any problems with this, you notice this being, you know, vastly uneven or something like that, or you're getting some weird performance, call up Energy. They have a fairly good
Sure.
with that. Let's go back to the controller here. So the controller, what I was seeing is that this battery is giving us an estimated state of charge as well there, estimated SOC, state of charge. So I'm not sure, though, to be honest with you, how it's gathering this information. I think it's gathering it based on the voltage reading off of the batteries. Again, which is technically more accurate than a state of charge. That state of charge can sometimes become, through some systems, although you don't have what we call a shunt, but sometimes there's a method where of monitoring the battery where things get there's a little bit of a error in the algorithmic calculation that it uses. And over time, over a period of days, weeks, months, that can reflect a wide variation between what the percentage state of charge is saying versus what the actual voltage is saying. The voltage is what matters. The voltage is what the actual is going to tell you what is really going on. So I'll be curious to see if there ends up being any difference in this. It might be worth doing a little reading on this, or you could do a search for lithium ion state of charge, like voltage chart.
Sure.
And that'll give you, just, let's say 13.6 volts equals 100%, 13.5 volts equals 95%, whatever it is. That might be worth having around too.
So this is where I'm also going to see the kind of the solar that's coming in.
Exactly.
Well, obviously we're inside, so it's in the garage, but
exactly, yes. This is going to give you the real-time reading. You can either look here or you can look here. So this basically is the same readout. It's very similar.
So it's not really a necessary piece of equipment.
So I don't see that as being necessary. Some people, they would, if you don't. I mean, most people nowadays have these pocket supercomputers on them everywhere they go, all hours of the day. So I just say do this. I'm actually going to be designing my systems more towards getting away from having the wall mount, because it's just one more piece of equipment you got to pay for.
Right.
And one more light on in here that you can get all that information right out of here.
Okay.
But it's totally dealer's choice. So if you want it, though, what you'd have to do is you'd have to hook this up to a positive and negative of the battery, so it's powered, and then you're going to replace it. You're going to replace this like the phone code, what's the RJ45 jack or whatever. You're going to take this Bluetooth module out, and you're going to hardwire it with that same type of wire into this thing, and that'll just give you the same information.
Okay.
I think that's all there is to talk about this. Let's flip around real quick over here.